Guys, what's up? We're here with day 36, review time. Today I'm gonna solve out the problems from the calculator one, the calculator required section, just because there were some questions today on how to use your calculator the correct way. But before we do that, I want to do just a little flashcard making activity. So if you have some note cards, or if you have a piece of paper that you can kind of tear into smaller pieces or cut into smaller pieces, these are just things that we need to automatically know all the time. And if you have a flashcard, it'll help you memorize them better. So here's how I want to do this. I'm going to put F on this side, B on this side for front and back, and you can kind of make these flashcards as you go. These are just things that we need to know automatically. Okay, so the first one is on the front, we have object at rest. Okay, the other word for rest, they might say stopped. What we need to know automatically about an object at rest or an object stopped, okay, that means it's not moving. That means its velocity is equal to 0. So anytime they're asking about an object at rest or an object stopped, we immediately need to know this is when v of t equals 0. So get to your velocity equation. You may be given it. If not, do a derivative to get to your velocity equation and set the whole equation equal to 0. That's all you have to do and solve for t. Okay. So that needs to be absolutely automatic. We do that every single time. Okay. The next thing I want is on the front of your card, we need to figure out when an object changes directions. This is related to object at rest or object stopped, but it is different. There are some significant differences. Okay? If they ever ask you, when does an object change directions? We automatically need to know. The first thing we go to is v of t changes signs. That's what we want to figure out. We know an object changes directions anytime v of t changes signs. Now, how could we know if v of t changes signs? Well, there's a couple of different ways here. On a graph, so let's say we have a graph of v of t. I'm looking for object crossing the t-axis, aka the x-axis. So it's got to be a 0, but it's got to be a 0 where we actually cross the axis. If we don't have a graph, if we're working with a function, what we want to do is, we know that v of t will change signs at 0. So we want to set v of t equal to 0. We want to solve for t. And then we want to do a sign test. So when we want to know when an object changes directions on a graph of v of t, right, we have to have a 0, but it has to be a 0 where we actually cross from minus to plus, right, from the lower half to the upper half, or we cross from the upper half to the bottom half. If it's an equation that we're working with, we want to set v of t equal to 0, solve for t, and do a sign test. We're only going to report answers if v of t actually changes signs at that 0, not just that it was equal to 0. Does that make sense? Next, Again, on the front of the card, it's going to be object going right. Or up. Okay? An object is going to be going right when? Well, what we're ultimately looking for is we're looking for v of t to be positive. So we're looking for our velocity to be positive. Anytime our velocity is positive, we're going right. So what does that mean? Well, let's talk about it in terms of a graph and in terms of a function. So let's say the graph is the graph of v of t. I'm going to report the region we want to report the interval where we're above the t-axis. Or x-axis. Okay? So anytime on our graph where we are above the t-axis, that's our interval. Okay? But what if we have a function? Well, we want to set v of t equal to 0, solve for t, and then again we want to do a sign test. And then we want to report where v of t is greater than 0. Okay. So we have to do a sign test whether we want to figure out if an object changes directions, because we need to see if velocity switches from plus to minus or minus to plus. But we also do a sign test on v of t to determine where the object is going right. Okay. You can make another flashcard with object going left, and just switch everything on the back side. V of t should be less than 0. The graph of v of t reported should be below the t-axis. And for a function, we set v of t equal to 0, solve for t, do a sign test, and report where v of t is negative. Okay. So I'm not going to make a whole other, write that all out. I'll let you do that. Okay, next. I want to know if an object has a speed increasing. If I want to know where an object's speed is increasing, let's say at time t equals a. So it might be 2, it might be 3, it might be 4, it might be 1.2, whatever. We'll just call it a, at any time a. So to know if the speed is increasing or if the speed is decreasing, I need to check two things. I need to check v of a's sign and a of, I shouldn't have chosen a of a's sign. So I need to check at that time the velocity and the acceleration. I'm just looking for the sign. I don't really care about the number, I care about the sign. Sign same. Speed is increasing. Sign's different. Speed is decreasing. So I need to check v of a's sign, or v of that time. Right? If it's t equals 2, I need to check v of 2, report the sign, a of 2, report the sign, and then make a call. Now when you explain on this, make sure you specifically use in your explanation v of whatever the time is and a of whatever the time is. Don't just say they are the same sign. Okay. The last one that's a little tricky is we want to report when an object has a speed of, let's say, 4. When does an object have a speed of 4? Okay? You got to be really careful with that word speed. We want to know, when does it have a velocity? I want to know, when is the velocity equal to 4? And I also want to know when the velocity is equal to -4. Okay? So this one I see most often asked with a graphing calculator. So what I would do is graph a horizontal line of 4, graph a horizontal line of -4, and find out when my velocity intersects those two horizontal lines. Okay, this is a very common problem that they do a lot on the free response. So we've seen it a lot, so if we see it, hopefully it's a free point for us on the test. Okay. So let's take a look at the calculator questions. I've got them copied right here. So here's what we have. A particle moves in a straight line following the equation v of t equals 1 plus cosine of 2t over e to the negative 0.2t for times 0 to 8. First thing that we need to know, this is calculator active. Our calculators are really, really, really good at some things. They're really good at graphing equations. They're really good at evaluating that at certain points. They're very good at doing numerical derivatives. It's really good at finding zeros and things like that. Okay? So there's a question. Question 2 is about acceleration. Now, if we didn't have a calculator, we'd have to do the derivative of that velocity equation. But since it's a numerical derivative, I'm just going to let the calculator do the work on problem 2. Right? Your calculator is your friend here. Let's use it to its best potential. Okay, so the first thing I want to do here is I want to graph my equation. The other thing I want to remind myself of, might be very helpful, this equation is the velocity equation. That should be obvious because it says v of t. Okay, but it's really, really, really important. That stupid update out of there. It's going to be really, really important to remember that the graph we're looking at is velocity. Okay? So what I want to do is I want to graph this thing. And I want to set up a good window so I can see it. Now, right away I know that my time t is between 0 and 8. So when I graph this thing, before I hit graph, sometimes these equations take a while to graph. I want to make sure that my window is set before I hit the graph button, so I don't have to change my window and regraph the whole thing. Remember, this is a timed test, and we want to do these things as quickly as possible. So I'm going to call up my calculator here, and I'm going to graph this equation. Okay, I think it's working. Now, here's the really important thing. When you're taking the AP test, you're going to be asked multiple questions about the same thing. Okay? So when we do this, it's going to be really important to graph this thing accurately the first time. We should only have to type in this nasty equation once. So we're going to type it in, and we're just going to do it carefully and make sure that there are no mistakes. Now you can see the problem is all about t, but our calculator always graphs in terms of x. So just anywhere you see a t, replace it with an x. Okay, so I'm going to do that in my y1. And I'm going to go ahead and type this in very carefully. 1 plus. Now I have a big fraction here. It's going to be to your advantage to use the fraction button on your calculator. You do that again by hitting the alpha button, then hitting y equals, then hitting enter. I don't see too many people struggling with that, so that's good. Now on top I'm going to have cosine of 2x And on bottom, I'm going to have e to the negative, I have e to the negative 0.2t. Of course, t means x here. Now, here's the important thing. I want to use exactly the same type of parentheses that they use as the question was written. This isn't a time to go rogue and determine where we should put some extra parentheses in or remove parentheses, right? Copy it exactly as it is. Also, I've seen people in the past, when they do negative 0.22t, that turns into negative 0.02, right? That's a different number. Be very careful and make sure it's transcribed perfectly. Okay? Now, before you hit the graph button, again, let's work on our window. I like using window much, much more than the zoom button. Okay? So we hit window here. I know that my t goes between 0 and 8. T is x, so I'm going to make sure my x is between 0 and 8. And oftentimes I just leave it as negative 10 to 10 here. I'll guess negative 10 to 10. If I need to change this a little bit later, I will. So I'm going to go ahead and hit graph. Take a look at what this looks like. So I see a nice kind of cool wavy line here. Now here's something where this screen is a little bit sharper on your TI-84. This right here, it might be difficult to tell if that is two distinct zeros with multiplicity 1, or it might look on your calculator like 1 0 with multiplicity 2. Okay? If it's kind of hard to tell, then what I would do is change my y min and max to be a little bit smaller. And then you might be able to see, right? On my calculator, I can clearly tell there's a gap right here, but on your calculator, it might be hard to see that. So I just want you to be aware of that. Okay, so I got my graph here. I'm ready to answer some questions. Let's go back and look at the first question. The first question says, what is the velocity at t equals 3? Okay. Again, remember, what I just graphed was velocity. If I want to know the velocity at t equals 3, all I have to do is trace the number 3. Now, you can trace in a couple of different ways on your calculator. Let's get it back up here. I think the easiest way is to just hit the trace button right here. Trace 3 and hit enter. And that y value of 2.749 is our velocity at time 3. The other way you can do it, which again, I don't know why you would do it this way, but just to show you it works, if you hit second calculate, this number 1 value is the same as trace. You hit enter, and then it'll want to know the x value, and you'll type in 3, you hit enter, and you get the same thing. But that's like 10 clicks, and just hitting trace 3, enter, is 3 clicks. So do it the easiest way possible, trace 3. Okay, so I'm going to report this answer. Now, if this is free response, I'm going to have 2 possible answers that I could write down. I could write down 2.749, or I could write down 2.750. If you're going to round this, you have to include that 0 at the end. You do not need to write both. Okay? So again, and I don't want to just write the number, I want to write v of 3 equals 2.750. Now, there are no units in this problem, so I don't need any units with my answer. Again, 2.75, bad. 2.750, good. On the multiple choice, it would be written as 2.750. That would be the one we would choose. They would not have 2.749 as one of your options, so don't worry about that. Okay? But they always write the rounded number on multiple choice. Free response, you're welcome to put 2.749 or 2.750. Okay, question 2 says, what is the acceleration at t equals 1? Well, the problem is I don't have an acceleration graph. If I did, I could just trace 1 on that graph. I have a velocity graph. How do I get from velocity to acceleration, you ask? Oh, well, easy. You just do a derivative and then plug in 1. Well, your calculator's already really good at this. You do not have to do a quotient rule with a chain rule here. This is not that complicated. All we have to do is do a numerical derivative. So again, I'm going to go back to my graphing calculator. Again, I want the derivative at 1. So I hit the second button, the trace button, and now down here, number 6 is derivative. Now all I want to do is trace the number that I'm doing the derivative at. I'll just hit 1, enter, and it reports it right here. Make sure you're reporting, if your calculator is like mine, dy dx equals negative 2.322, or you could put negative 2.323. Don't report these numbers. That's not what this is about. If you have one of the black and white ones, it'll only give you dy dx equals. Okay? So this is the answer we want right here. So we're going to report that on our paper as negative 2.323. I'm not just going to write the number. I'm going to say a of 1 equals negative 2. Oh crap! What was it? Have to look it up. Negative 2.322. Or I could write negative 2.323. I rounded my first answer. I truncated my second answer. That's okay. I can do whatever I want as long as it's one of those two options. Question 3 says, at what times on the interval 0 to 8 did the particle change directions? Well, that was one of our flashcards, right? We know a particle, whatever this thing is, changes directions anytime v of t switches signs. I need to make sure I'm working with the correct interval. The interval says 0 to 8. Notice that it's in soft parentheses. So 0 and 8 couldn't be answers, but anything in between 0 and 8 can be an answer. Okay, and I'm looking for v of t to change directions. Then I also have to explain. So let's go back to my graph. So I'm looking for velocity changing signs. Remembering here that my velocity is what I have graphed. Right? So I'm looking for zeros, but I'm looking for zeros where I specifically cross the t-axis. Now here's one. If your calculator's in black and white, you might want to shrink that window, that y window, just a little bit. Don't mess with the x window. We still want 0 to 8, but go ahead and shrink that y window. Maybe do negative 5 to 5, and it might make it a little bit clearer that we have two separate zeros there. Okay. So all of the zeros I see here, the velocity switches, right? So this first 0 right here, my velocity is positive because it's above the axis, and then it's negative below. So this 0 is going to be an answer. So is this 0, this 0, this 0, and this 0. So I'm going to have 1, 2, 3, 4, 5 answers here, and I'm going to write them all down. Now to find those zeros, right, to find those zeros, I need to do second calc number 2. Okay? Now it's going to ask for a left bound. Right? It always starts you right in the middle of the graph. So I just got to arrow over. I'm just going to hold this down until I'm on the left side of the 0. Okay? That's a left bound. I'll hit enter. Now I want to get on the right side of the 0 that I want. Okay, and to the right of it, I'm going to hit enter, and then I have to hit enter one more time. So my first one is 1.233. I'm going to just truncate that. I don't want to worry about screwing up the rounding. So I'm going to say 1.233. Now I have to quickly find all these other zeros. There's kind of a lot of them, right? So I'm going to go ahead and do this quickly. Just kind of watch my work here. Second calc 0. I want to be on the left bound of my next 0. That's good enough. I want to be on the right bound. I'm going to hit enter one more time. My next one is 1.987. Again, I can round or truncate. I'm just going to truncate because it's easier for me. Find the next zero. I'll do second calc number 2. Let me show you another way you can do these zeros. My next zero I'm looking for is right here. When I can go left bound, right bound by scrolling, or I can just type in numbers, right? So 1, 2, 3, 4 looks like it's on the left bound. So I'm just going to press 4 and hit enter. And then it wants right bound. Looks like 5 is on the right side. I'm going to hit 5 and hit enter. Right, and now I've got that zero cornered from the left and from the right, and I'm just going to hit enter. It's another option for you if you don't like to scroll. So my next one is 4.152. Alright, got 2 more to report. I'm going to do them the fast way. Okay, so I'll do second calc number 2 for 0. My left bound here, I'm going to use 1, 2, 3, 4, 5. My right bound, I'm going to use 6. And hit enter. And there we have the next one at 5.321. And my last zero, I'll do second calc number 2. Left bound, I'm going to use 7. Make sure it's left of my zero. It is. Okay. Right bound, I'm going to use 8. And I'm going to hit enter one more time. I get 7.188 as my last one. Okay, so those are my answers, but if I don't explain, I'm in jeopardy of losing all these points that I've so painstakingly found. Okay, my explanation is these are the times when what happens? Well, this is when V of t changes signs. Question 4. Oh, by the way, when you do that explanation, make sure you say V of t and make sure you say changes signs. That's the most important thing that's in there. If you say this is when it changes signs, no credit. Sorry, not specific enough. Number 4, how many times in the interval 3 to 5 did the particle have a speed of 1? A couple of things jump out at me here. My interval has now changed from 3 to 5. And I see this word speed of 1. Okay? So a speed of 1 is going to occur with a velocity of positive 1 or a velocity of negative 1. But I also have to change my window. So here's what I'm going to do. I'm going to go here. I'm going to switch my window to be from 3 to 5 because that's what they asked for. I'm also going to go to my y equals, and I'm going to, please don't delete y1, keep that in there. We don't want to retype that whole thing. But in y2, I'm going to enter 1, and in y3, I'm going to enter negative 1. Now I'm going to graph. So here's my velocity, chugging along. Here comes my 1 and my negative 1. Right away, I see that there are going to be 2 times when I have a speed of 1. Once again, on your calculator, it might be tough to see if there's a gap here or if they intersect. Right? Just shrink your y window a little bit to see that. Now I want to find those 2 times when they hit. Okay? To find that, I need to do intersection. So I'll do second calc. Number 5 is intersect. And I'm going to hit enter on my first curve. I'm going to hit enter on my second curve, making sure it's going towards the actual one that I want. I'm going to hit enter one more time. I get a t-value of 3.926. So I get a t-value of 3.926. Doing that again, I'm going to switch back to my other calculator here. And I want to find that next intersection, so I'll hit second calc intersect. I'll just move my cursor. Oops. Second calc intersect. I'm going to move my cursor closer to that last intersection. I'll hit enter. Ooh, no, it's wanting me to use that Y2 line. I don't want to use that line. I'm going to hit the down to use Y3, hit enter, and enter one more time. 4.414. Okay, those are the 2 times. They didn't ask me to justify, but they did ask how many times on the interval. So the answer is 2 times. And those are the specific times. All right, class is ending and this room is about to be used, so I need to sign off. We'll finish the rest of this later. Talk to you later, guys. Bye.